Hello everyone, my name is Mohammad Iqbal and I am an IIT engineer who graduated from IIT Madras with a BTech and MTech in electrical engineering. I have been training students for the past 8 years for various competitive exams like JEE Main and JEE Advanced, ISI, KVPY and Math Olympiad. Currently I am head of department at Coach India IITians Academy, an institute in Kerala. I have also recently won Reliance Foundation Award for being All India Rank 2 in teaching professional Olympiad conducted by Centa and Hindu. So today we'll have a look at one question that came in IIT JEE Advanced 2013. So the question was also repeated in JEE Main 2019 with slight modification. So let's quickly have a look at the question. So here is the question. The value of cot of sigma n is equal to 1 to 23, cot inverse of 1 plus sigma k is equal to 1 to n, 2k is. So when you look at the question, this looks very complicated because there are too many brackets, there are too many sigma signs, and there is cot and cot inverse involved. But when you look at the options, that gives you a relief because the options are pretty simple numbers, right? So I'll tell you how to do this. I'll also tell you how to do this in 10 seconds. Okay, after doing the normal method, I'll also give you a shortcut to do this. Okay, so let's look at this question. Let's try to analyze this problem. So first of all, you see that there is a sigma k is equal to 1 to n 2k here. So the sigma k is equal to 1 to n 2k is nothing but 2 times sigma k is equal to 1 to n k. So this is nothing but the sum of first n natural numbers, and that is n into n plus 1 by 2, and there is a 2 that gets cancelled, so that is n into n plus 1, right? So let's go and substitute this here. So this expression becomes 1 plus n into n plus 1, and now there is a cot inverse here. I don't like cot inverse. What do I like? I like tan inverse. So I have to replace this cot inverse with tan inverse. So that expression, so let's forget about this cot for the time being. Let's look at this expression and let's replace this cot inverse with tan inverse. So this cot inverse of 1 plus n into n plus 1 is going to be tan inverse of 1 by 1 plus n into n plus 1. Why? Because this cot inverse of x is going to be tan inverse of 1 by x in this case. So this is going to be sigma n is equal to 1 to 23. See, I am replacing cot inverse with tan inverse. So tan inverse of, see, originally we have 1 plus n into n plus 1. So when I replace cot inverse with tan inverse, it is going to become 1 by 1 plus n into n plus 1. Okay, of course, let's forget about the cot which is lying outside for the time being, right? So the next step is crucial. So this is a very popular form which is frequently asked in exam. So this is very popular with exam paper setters, even in JEE Main, JEE Advanced, whatever exams you consider, this is a very popular form. Okay, so what we have to do is we have to write this as a telescoping series. Okay, so the idea is you have to split this expression, either, see, here we have a summation. Okay, so the idea is each term of the summation, I'm going to split it into 2 terms. And what will happen next is the consecutive terms will keep getting cancelled. Okay, that is the idea of problems involving telescoping series. So, see, the trick I'm going to use here is, see, listen carefully. There is a 1 on the numerator. So that 1, I'm going to rewrite it as n plus 1 minus n. Okay, so this is a very popular trick. You should be very familiar with the trick. Then only you will be able to spot such kind of questions. So when you see this part, you should be able to quickly identify that this involves using a telescoping series, and then only you will be able to move on to the next step. Okay, now look at this expression. Now this is tan inverse of n plus 1 minus n by 1 plus n into n plus 1. So this is a common result, right? Tan inverse of x minus y by 1 plus xy. So the idea is we can split this, we can rewrite this. So in the next step, I'm going to rewrite this tan inverse of x minus y by 1 plus xy as tan inverse of x minus tan inverse of y. Okay, so far so good. Cool. Fine. Yes, so let's move on. So what do I have now? We have sigma n is equal to 1 to 23 tan inverse of n plus 1 minus tan inverse of n. Now rewriting in this way is going to do all the magic, because when you look at this, you observe that when you put n is equal to 1, this is tan inverse of 2 minus tan inverse of 1. Okay, and the next term is tan inverse of 3 minus tan inverse of 2. Okay, next term is tan inverse of 4 minus tan inverse of 3, and so on. The last term is going to be tan inverse of, when you put n is equal to 23, it is going to be tan inverse of 24 minus tan inverse of 23, right? Okay, so this looks cumbersome, but wait for it. I'll give you a quick shortcut to do it. After doing this way, I'll also give you a shortcut, so wait for it. Now, as I said, look at this. Look at this. This is tan inverse of 2 minus tan inverse of 1. The next term is tan inverse of 3 minus tan inverse of 2. Next is tan inverse of 4 minus tan inverse of 3, and so on. So a lot of terms gets cancelled, right? See, this tan inverse of 2 gets cancelled with tan inverse of 2 here. This tan inverse of 3 gets cancelled with tan inverse of 3 here. Similarly, it keeps getting cancelled. So what will be remaining? See, even this tan inverse of 23 will be getting cancelled with the first term of the previous term. First entry for the positive expression of the previous term. Okay, so what will be remaining? This tan inverse of 24 will be remaining, and this tan inverse of 1 will be remaining. Okay, so what is left is tan inverse of 24 minus tan inverse of 1. Okay, now again we can use this expression as tan inverse x minus tan inverse y as what? Tan inverse of x minus y by 1 plus xy. So that is tan inverse of 23 divided by 25. So don't forget about the cot which is lying outside. So ultimately this is cot of tan inverse of 23 by 25. Now this tan inverse is nothing but cot inverse of 25 by 23. Okay, so the answer is 25 by 23. 25 by 23 is our answer. So this question appeared in JEE Advanced 2013, and this question came again in 2019 JEE Main with slight modifications. Instead of 23, some other number was asked, right? Okay, cool. So that's good. Okay, it's easy problem, but we have used a standard trick of writing the series as a telescoping series. Now let's go to the shortcut. Okay. Now when you look at this question, I just told you when this question was repeated in JEE Main, instead of 23, some other number, if I remember correctly, it was 19. Now when you look at this question, what is the most striking feature about this question? What is so striking about this question? What is so special about this? The special thing is 23, right? Why on the earth would someone give me a number like 23? What is so special about 23? Why can't it be 2020? Why can't it be 2013? Why just 23? Okay, and when you look at the options are also related to the number 23. So had it been another number n, say instead of 23, had it been some capital N, your options look like this: n by n plus 2. This is n plus 2 by n, and this is n by n plus 1, and this option is n plus 1 by n. Okay, so how do I think? I look at the question and I'm struck by the number 23. What is so special about this number 23? There's nothing special about the 23. Okay, this question would have been framed by giving some other number as well. So think about it. So when you look at this number 23, the options are also related. So I replace the question. I'm going to generalize the question. I'm going to think from the perspective of the question paper setter. Okay, so this is the question now. Now again, n can take any value, right? N can take any value. So I'm going to put capital N as 1. I'm going to put capital N as 1. Okay, now what does this mean? This n is varying from 1 to 1. Okay, so here in this case, k is varying from 1 to 1. So there is just one term here, which is 2 times 1. This is 3. So we have cot inverse of 3, which is nothing but 3. So when I put capital N is equal to 1, the answer is 3. And this is the matching option. Okay. It was so quick, right? If you can think fast and sharp, the answer will come out in just 10 seconds. Okay.